Good afternoon. This is a demonstration of the flight mechanics of a project I've been working on for Quadcopter. Here in Simulink, I'm calculating the rotational dynamics, rotational kinematics, translational dynamics, and the translational kinematics, and outputting the visuals to flight gear. This is running in MATLAB with visuals being performed by flight gear. Here we have body accelerations, U.V.W. We have UVW, so body velocities, translational velocities, body rotational accelerations, and body rotation rates, PQR. Right here we have the inputs. So we have thrust, LMN are the moments about the body XYZ axes, which are controlled with a joystick. The thrust is also controlled with a joystick. And up here we have the inertial velocity rates. So X dot, Y dot, Z dot. Z positive being down. For the simulation, imagine this Cessna is a quadcopter, and the flight mechanics will make more sense. So the thrust will be in the body Z, negative body Z direction. So it'll be coming out the top as if it's thrusting down, pushing the quadcopter, or in this case the Cessna, up. When it starts, it'll be in a hover. And let's get to the demonstration. It's going to initialize. So we start off, we're in a hover. I'm going to start by decreasing the throttle to 0. You can see here that thrust went down to 0. I was initially, and now I'm going to increase to full throttle until I arrest my descent, and I come back to a steady hover 0. Now I should be at about a constant altitude. Looks like I'm slightly going up, but that's okay. I'm going to tilt forward, so I'm going to push down, push forward with the joystick. Now I need to arrest my Q right here, so I'm going to pull back. Q is approximately 0, so I should be, now you can see my velocity vector is taking me down because I haven't increased thrust, so I need to increase thrust so that I am not descending. So now I have 0 vertical velocity, near 0 vertical velocity, so I'm maintaining altitude. Trimming my thrust to keep altitude. You can see I'm accelerating in the forward direction. This model does not use aerodynamic forces, so I have nothing to slow me down. I have no drag force to counteract my forward acceleration. Now I'm going to rotate right. I'm going to yaw to the right. And now I need to yaw back left to counter and bring myself to a standstill again. And there we go. Oh, overshot. Right now I'm looking up here to bring my rotation rate R back to 0. So I no longer have a rotation rate. I am accelerating. I'm going to roll to the right, and I'm going to increase thrust and try and arrest my lateral motion. I'm going to roll back left to, there we go. There we go. And now you can see in the top right, the yellow line is coming down quickly. So that means my lateral velocity is almost back to 0. I'm going to increase thrust a little bit more, pull it back down, and now I need to roll back left. Looks like I'm actually going backwards a little bit. There we go. And increase thrust back to match mg, and I'm almost back to a perfect hover.